What if the universe you see around you, every star in the night sky, every memory you hold dear, even the device you're watching this on right now, was nothing more than an elaborate simulation? A vast, intricate code running on some unfathomable supercomputer far beyond our comprehension. It sounds like science fiction, but some of the brightest minds in physics, philosophy, and tech have seriously entertained this idea. Elon Musk famously claimed the odds we're living in base reality are 1 in billions. The Matrix didn't just make for gripping cinema, it tapped into a question that's haunted thinkers for centuries. How do we know any of this is real? This isn't just wild speculation. The simulation hypothesis is a legitimate theory with roots in cutting-edge science and ancient philosophy alike. From Plato's cave to quantum physics, the idea that reality might be an illusion keeps resurfacing in startling ways. And today, with advancements in virtual reality, artificial intelligence, and our understanding of the cosmos, the argument feels more plausible than ever. Could the glitches we sometimes notice, déjà vu, unexplained coincidences, even dreams that feel too vivid, be tiny cracks in the simulation's facade? In this video, we're diving deep into 30 compelling reasons why our universe might not be what it seems. Some will make your spine tingle with their eerie plausibility. Others will challenge everything you thought you knew about existence itself. We'll explore cosmic anomalies that defy explanation, strange patterns in mathematics and nature that seem programmed, and even the unsettling possibility that you watching this, might be the only real thing in this entire digital mirage. Strap in. By the end, you might never look at reality the same way again. Let's start with something mind-bending. What if the universe isn't smooth and continuous like we perceive it, but actually pixelated just like a video game? At the smallest scales, reality gets fuzzy, almost as if it's loading details only when we look. This isn't just speculation. Quantum mechanics backs it up. Take the famous double-slit experiment. When scientists fire particles at a barrier with 2 slits, they behave like waves unless someone observes them. Then suddenly they act like solid particles. It's as if the universe is conserving processing power, only rendering reality when it's being watched. Then there's the Planck length, the smallest possible measurement in physics. Beyond this point, the concept of distance breaks down. Sound familiar? It's eerily similar to how video games have a minimum resolution. Try zooming in too far on a digital image, and you hit a blocky limit. Could the Planck length be our universe's built-in pixel size? Even time might not flow smoothly. Quantum jumps suggest that changes happen in discrete steps, like frames in a simulation updating at a fixed rate. Think about how video games optimize performance. Distant objects are low detail until you approach them. Now consider quantum entanglement, where particles instantly influence each other across vast distances. Could this be a clever shortcut, a cosmic version of loading linked assets in advance to save resources? The deeper you look, the more reality seems to operate on rules that feel less like laws of nature and more like a clever programming hacks. Now let's talk about something even stranger, the universe's eerie obsession with math. Think about it. Galaxies swirl in perfect spirals following the Fibonacci sequence. Planets orbit with clockwork precision, and even the randomness of quantum particles fits into statistical models. It's as if reality runs on a set of flawless equations, like lines of code in some grand cosmic program. Take gravity, for example. It doesn't just sort of pull things together, it obeys an exact inverse square law. Drop an apple and its speed increases by 9.8 meters per second squared. Every single time. That level of consistency feels less like chance and more like a developer hard-coding physics into the simulation. Even the chaos we see, turbulent weather, colliding galaxies, follows predictable patterns when you crunch the numbers. Then there's the golden ratio, a mathematical constant that pops up everywhere. Seashells grow in logarithmic spirals that match it. Sunflower seeds arrange themselves along these precise curves. Human DNA contains twists separated by these proportions. If nature were truly random, why would unrelated phenomena keep converging on the same elegant number? It's as if the universe is running on a template, recycling the same elegant algorithms to save processing power. Here's the kicker: math itself might be the biggest clue. Physicist Eugene Wigner once called its effectiveness in explaining nature unreasonable. Why should abstract human inventions like calculus or algebra describe black holes or chemical reactions so perfectly? Unless, of course, math isn't something we invented at all. Maybe it's the simulation's native language, and we're just deciphering its source code piece by piece. But wait, shouldn't a real universe be messier, less predictable? Even in chaos theory, there's hidden order. The more we study reality, the more it feels like a meticulously debugged system. So the next time you see a pinecone spirals or hear a musical harmony that resonates just right, ask yourself, are you witnessing nature or reading the universe's instruction manual? Ever experienced something that made you question your own memory, like swearing Nelson Mandela died in prison in the 1980s, only to learn he lived until 2013? You're not alone. Millions share this exact false memory, a phenomenon so widespread it's called the Mandela Effect. But what if these collective misrememberings aren't mistakes at all? Could they be tiny errors in the simulation's code, brief moments where the program glitched, revealing a previous version of reality before the developers patched it? Then there's the Berenstain Bears mystery. Thousands insist the children's book series was once spelled Berenstein with an E, yet every piece of evidence now shows it was always Berenstain. How could so many people independently misread the same word for decades? Skeptics blame faulty memory but dig deeper and the anomalies multiply. The Monopoly Man's monocle never existed. Darth Vader's famous line, "It's no, I am your father," not "Luke, I am your father." These inconsistencies pile up like digital artifacts, as if someone edited the simulation script and forgot to update all the backups. Physics has its own glitches. Take NASA Pioneer anomaly. In 1972, the Pioneer 10 and 11 spacecraft drifted slightly off course, defying all known laws of motion. For decades, scientists scrambled for explanations. Was it fuel leakage, thermal radiation? Eventually, mundane answers emerged, but the mystery lingers. Could it have been a rounding error in the universe's physics engine, a hiccup in gravity's code? Quantum mechanics doubles down on the weirdness. Particles behave one way when unobserved, existing as probability waves, but collapse into definite states the moment we measure them. It's as if the simulation is lazy, skipping the hard work of calculating outcomes until forced to. Even stranger, delayed choice experiments show that our observations today can alter a particle's behavior in the past. That's not just counterintuitive, it's downright broken, like a game struggling to retroactively render decisions to save processing power. And what about dreams? Those hyper-vivid, emotionally charged worlds we construct every night, could they be the simulation's way of defragging our minds? Or worse, glimpses into parallel versions of the code running in the background. The more you scrutinize these cracks in reality, the harder it becomes to shake the feeling that somewhere, someone might be debugging the universe around us, and we're just noticing the patches. Have you ever stopped to notice how many of your daily actions unfold on autopilot? The way you scroll through your phone without thinking, follow the same route to work, or even replay familiar arguments in your head. These routines might feel mundane, but they point to something far stranger. Studies suggest up to 90% of our thoughts are recycled loops, like a playlist stuck on repeat. Now picture the non-player characters in a video game. Those background figures walking preset paths, spouting the same few lines. The resemblance is unsettling. Could human behavior, with all its apparent complexity, actually follow coded patterns just like NPCs. Look around. Crowds move through crosswalks like synchronized algorithms. Office small talk leans on predictable scripts, weather, weekend plans, the occasional complaint about Mondays. Even our emotional reactions often follow societal templates: laughter at expected moments, outrage over pre-approved topics. Psychologists call this social scripting, where cultural norms dictate behavior so thoroughly that individuality starts to feel like an illusion. Games mimic this deliberately. NPCs in Grand Theft Auto or Skyrim don't improvise, they pull from a limited pool of responses. Yet humans, despite believing in free will, often operate the same way. Neuroscience adds another layer. Brain scans reveal that decisions we believe are spontaneous, like choosing a snack, show neural activity seconds before we're consciously aware of making a choice. It's as if our brains run background processes and we merely rationalize the outcomes after the fact. Philosopher Daniel Dennett compares this to a game's AI. Deciding which tree to render next, the player never sees the calculations, only the result. Then there's conformity experiments like Ash's famous line tests, where people denied obvious truths to match group behavior. In a simulation, this groupthink could be a resource-saving feature. Why code billions of unique reactions when herd mentality keeps things efficient? Even creativity has limits. Artists and inventors often remix existing ideas rather than conjuring wholly new ones, like NPCs given slightly varied dialogue trees. But here's the twist: if we're NPCs, who's the player? Maybe consciousness isn't universal. Some theorists suggest only a fraction of beings are truly awake, while others fill roles as background characters. It'd explain why some people seem to break scripts: artists, rebels, those who defy social coding, while most follow the programmed grooves. Next time you catch yourself nodding along to a conversation without listening, ask, are you choosing the path, or is the simulation choosing it for you? Why does nothing in the universe move faster than light? Physics tells us it's a fundamental limit, but what if it's not a law of nature so much as a hardware restriction? Think about your computer struggling when too many apps run at once. To prevent a crash, it throttles performance. Now imagine the cosmos as software. The speed of light, that universal speed limit of 299,792,458 meters per second, could be the simulation's built-in failsafe, a maximum processing rate to keep reality from glitching into chaos. Video games use this trick all the time. Open-world titles cap frame rates or reduce distant object detail because rendering everything at once would melt your graphics card. Even simple games like Pac-Man have screen wrap. When you exit one side, you reappear on the other, not as a feature but to save memory. Our universe might operate similarly. Einstein showed that as objects approach light speed, time slows down for them relative to everything else. This time dilation looks suspiciously like a system prioritizing resources, slowing local clocks to handle extreme velocities without overtaxing the processor. Black holes take this further. At their event horizons, time appears to stop entirely from an outside perspective, like a frozen program waiting for inputs. Meanwhile, quantum entanglement allows instantaneous correlations across space, but crucially, no information travels faster than light. It's as if the simulation cheats by pre-loading linked states, then enforcing light speed as a buffer to prevent data overload. Even the vacuum of space isn't truly empty. It crackles with quantum fluctuations, energy simmering at the smallest scales. Could this be the cosmic equivalent of background processes, the simulation's idle hum as it maintains the framework of reality? Here's the chilling part. If light speed is a processing cap, our attempts to breach it warp drives. Wormholes might not just fail, they could trigger errors. Imagine forcing a game to render what its engine wasn't designed for. The result: crashes, corrupted saves. If we ever cracked light speed, would we hear the universe itself blue screen? What if everything you remember, your first kiss, your childhood home, even the history books gathering dust on your shelf, was fabricated just moments ago? This isn't a plot twist from a sci-fi novel. It's the Last Thursday theory, a mind-bending take on simulation logic. The idea is simple. The universe, complete with all its apparent history, might have been generated last Thursday, preloaded with fake memories, fossils, and light from distant stars to create the illusion of depth. Think of it like booting up a video game where the lore scroll claims centuries of backstory, but the code was actually written yesterday. Archaeology offers eerie glitches that fuel this theory. Take the Antikythera mechanism, an ancient Greek device so advanced it resembles a 2,000-year-old computer. How did such precision exist in a world that wouldn't rediscover those mechanics for another millennium? Or the Baghdad batteries, clay pots that seem to function as primitive batteries, though mainstream history insists electricity wasn't harnessed until much later. These anomalies feel like rendering errors, as if the simulation rushed to populate timelines and missed a few details. Then there's the Mandela Effect on a cosmic scale. Entire civilizations have myths that overlap suspiciously, flood stories, dragon legends, star maps aligned to constellations that no longer match our sky. Could these be reused assets, like a game developer recycling textures to save time? Even carbon dating isn't immune. Tiny discrepancies in decay rates have surfaced, blamed on calibration errors. But what if it's deeper? A slight miscalibration in the simulation's historical timestamp generator. Here's the kicker: false memories might be the smoking gun. Neurologists know our recollections rewrite themselves constantly. That vivid childhood birthday, studies show we often graft details from photos or stories told later. In a simulation, this fragility makes perfect sense. If history is a dynamic construct, not a fixed record, malleable memories would be essential for patching inconsistencies on the fly. So the next time you stare at a textbook, ask yourself, is this the weight of millennia or just a very convincing save file? Where is everybody? That's the haunting question behind the Fermi paradox, the eerie silence of the cosmos despite billions of potentially habitable planets. If the universe is teeming with life, why haven't we found a single shred of evidence? One chilling answer: advanced civilizations know Earth is off limits because they're players in the same simulation, respecting invisible boundaries like gamers avoiding a restricted server. Consider how multiplayer games handle newbies. Veteran players might avoid starter zones to let novices learn the ropes or risk getting banned for interference. Now scale that up. UFO sightings from Roswell to military jet encounters could be admin visits, higher-level users popping in to check on Earth's progress or debug glitches. Those infamous tic-tac UFOs captured by Navy pilots with impossible acceleration and no visible propulsion. They might not be crafts at all, but diagnostic tools scanning our region for errors like a cosmic antivirus program. Even the government's sudden UAP transparency fits. If the simulation's code updated to allow more user visibility, it'd explain why officials are suddenly admitting they've tracked these phenomena for decades. Ancient astronaut theorists love pointing to cave paintings of strange beings or biblical accounts of fiery chariots. But what if these weren't aliens, just players from earlier versions of the sim? Their access revoked after the developers patched the rules. The zoo hypothesis, the idea aliens observe us like animals in a preserve, gets a digital twist here. In open-world games, NPCs sometimes react when you breach hidden areas, as if suddenly aware they're being watched. Crop circles, cattle mutilations, even oddball abduction stories could be the simulation's equivalent of bugs triggered by unauthorized observation. And why would higher-level users care? Simple: preserving the experiment. If Earth's a sandbox for studying primitive consciousness, contamination ruins the data. It's why UFOs vanish when pursued, like a dev toggling off visible mode when players get too curious. The truth might not be that we're alone, but that we're quarantined, our planet tagged with an invisible "Do Not Disturb" sign in the cosmic code. So next time you gaze at the stars, wondering why they stay silent, consider this. The silence itself might be proof we're not just players in the universe, but characters in someone else's game, and the admins are watching. Picture two particles separated by billions of light years. Yet when you change one, its partner instantly mirrors that change faster than light should allow. Einstein called this spooky action at a distance, and it baffled him for good reason. But what if this quantum entanglement isn't magic? What if it's just the universe's version of network lag-delayed data packets between cosmic servers struggling to stay in sync? Gamers know this frustration well. In an online match, your screen might show a player teleporting because your console hasn't received their latest position data yet. The server reconciles the gap moments later, snapping everything back into place. Quantum entanglement could work the same way. When we measure one particle, its state update hasn't fully propagated to its entangled twin yet, hence the apparent instant connection. The reality, the simulation's backend is still playing catch-up, stitching together coherence across vast distances like a cosmic IT admin racing to fix desinced multiplayer lobbies. Even weirder, the delayed choice experiment. Scientists can wait until after a particle passes through a detector to decide whether it behaved like a wave or a particle. It's as if the universe renders outcomes on the fly, adjusting history retroactively when new data arrives, like a game client rubber banding to compensate for sudden latency spikes. Minecraft does this visibly. Break a block with high ping, and it might reappear briefly before vanishing. Could quantum uncertainty be our universe's version of placeholder graphics, masking incomplete calculations? Here's the clincher: entangled particles don't actually transmit information faster than light. They just correlate in ways that look instantaneous, exactly how two players in different time zones might see the same in-game event simultaneously, despite one's connection lagging. The simulation doesn't need to violate its own light speed rule. It just front-loads the relationships, then syncs the apparent results locally. So next time you rage at multiplayer lag, take comfort. Even the cosmos might be buffering. Those spooky quantum connections, they could just be the universe's way of telling you, please wait, rendering in progress. What if your sense of self, the voice in your head reading these words right now, isn't some mystical essence, but the output of an impossibly complex calculation? Modern neuroscience paints a startling picture. The brain's 86 billion neurons fire in precise patterns, converting electrical pulses into everything you perceive as reality. This biological supercomputer doesn't just process information, it generates your entire lived experience, from the sting of a paper cut to the warmth of nostalgia. In essence, your mind might be the universe's most sophisticated rendering engine, constructing consciousness frame by frame like a GPU building a virtual world. Artificial intelligence gives us eerie parallels. Large language models like ChatGPT produce shockingly human-like text by predicting word sequences, not through understanding. Yet to an outsider, the result feels indistinguishable from sentience. Google's DeepMind mastered chess not by intuiting strategy, but by crunching probabilities, and still plays with what appears like creativity. These systems suggest consciousness could emerge from pure information processing, no soul required. After all, if silicon can simulate thought, why couldn't evolved wetware do the same? Philosopher David Chalmers nails the paradox. Even if we perfectly map the brain's wiring, we still can't explain why electrical storms in cranial tissue should feel like anything at all. This hard problem of consciousness vanishes if experience itself is a simulated property, a user interface your brain generates to navigate reality. Consider dreams. Your mind builds fully immersive worlds while your body lies paralyzed in bed. If your subconscious can render convincing realities offline, why assume waking life is any more real? The implications spiral. Neuroscientists find decision-related brain activity up to 7 seconds before subjects report making a choice. It's as if consciousness is the last department notified, like a game character, realizing it turned left only after the command was executed. Patients with split brain syndromes, where the brain's hemispheres are surgically separated, demonstrate even stranger behaviors. When shown different images to each eye, one hand might button a shirt while the other unbuttons it, each side inventing plausible explanations for actions it didn't initiate. These aren't glitches, they're features of a system where narrative selfhood is a built-in illusion, stitching together post hoc justifications for decisions made elsewhere in the code. Perhaps the most unsettling clue lies in brain stimulation experiments. Surgeons probing exposed neurons with electrodes can induce involuntary laughter, vivid flashbacks, even out-of-body experiences, all by tweaking specific neural circuits. Patients report these artificial stimuli as seamlessly real as organic memories. If consciousness is so easily hacked by physical inputs, how much of yourself is truly yours, and how much is the simulation running on autopilot? Here's the twist. AI researchers increasingly treat human cognition as a benchmark for machine intelligence. But what if that's backward? Maybe we're not building machines in our image, we're reverse engineering the processor that already built us. Every time you recognize a friend's face in milliseconds or intuit a social cue without thinking, you're demonstrating the universe's original neural network, operating on hardware we're only beginning to decode. The question isn't whether machines can become conscious, it's whether we ever were. Every open-world video game has boundaries, an invisible wall at the edge of the map where the render distance ends. Now imagine peering through the most powerful telescopes, measuring the cosmic microwave background, and discovering something eerily similar. Our observable universe spans roughly 93 billion light-years and beyond that. Nothing, no galaxies, no light, not even empty space as we understand it. Just an abrupt cutoff, like a simulation hitting its memory limit. This cosmic horizon isn't just a technological constraint, it defies our intuitive notions of infinity. Ancient philosophers and modern theorists alike assumed the universe stretched endlessly, but measurements show it's curiously finite. Even stranger, the cosmic microwave background, the afterglow of the Big Bang, displays uniform temperature in every direction, as if someone copy-pasted the same skybox texture in all directions. In an infinite cosmos, you'd expect turbulent variations, pockets of chaos. Instead, we get pixel-perfect consistency, like a procedurally generated world optimized for performance. Compare this to games like Minecraft. Their worlds feel infinite, but dig far enough, and you hit the far land's glitchy terrain where the math breaks down. Astronomers observe analogous limits. The Hubble volume, the sphere of space we can theoretically observe, might be our version of those far lands. Light from beyond hasn't reached us yet, not because it doesn't exist, but because the simulation hasn't rendered it. Some theorists propose the universe could still be infinite, outside our observable bubble, but here's the catch: we'll never know. The expansion of space accelerates faster than light can cross it, permanently locking us in our local server. Physics compounds the mystery. The universe's total mass energy, calculated down to the decimal, balances perfectly to allow complex structures like galaxies and life. Tweak it slightly and everything collapses or dissipates. This fine-tuning resembles a game developer carefully setting boundary conditions so players don't crash the system. Even the shape of spacetime is suspiciously flat, a geometric miracle that avoids the chaotic curvature you'd expect from random natural processes. Perhaps the most haunting clue lies in black holes. These cosmic drains don't just crush matter, they erase information, violating quantum physics' core tenet that data can never be destroyed. Unless, of course, the data isn't gone, just compressed or deleted to free up storage. Astrophysicist Stephen Hawking once suggested black holes might emit scrambled remnants of that information as radiation. It's the universe's equivalent of emptying the recycle bin. So when you gaze at the night sky, remember, you're not just looking at stars. You might be staring at the edge of the simulation's rendering distance, where the engine stops drawing new celestial objects because the player, that you hasn't traveled close enough yet. And just like a game, the universe might not bother generating what we can't see. 14th century philosopher William of Ockham had a simple rule for cutting through confusion. When faced with competing explanations, the one requiring the fewest assumptions is usually correct. His famous razor has guided scientists for centuries, and if we apply it to reality itself, the conclusion is startling. Building a universe from scratch with all its arbitrary constants and messy evolution is astronomically complex. But simulating one that could be far simpler. Consider the numbers. Physicists calculate the odds of our universe's life-permitting conditions emerging randomly at less than 1 in 10 to the power of 230. That's like winning the lottery every second for 1 trillion years, or while being struck by lightning each time. Yet if advanced civilizations routinely create ancestor simulations, digital reconstructions of their past, the math flips. Oxford philosopher Nick Bostrom's statistical argument suggests most conscious beings would almost certainly be simulated rather than biological. Why? Each real civilization could spawn billions of simulations, making simulated minds the overwhelming majority. You're statistically more likely to be code than carbon. Think about video game design. Creating a hyper-realistic forest isn't done leaf by leaf. Developers use algorithms to generate textures, physics engines to mimic wind, and AI to populate wildlife. The simulation hypothesis extends this efficiency to cosmic scales. Our universe's elegant mathematical structure, from the Fibonacci spirals in galaxies to the exact force binding atoms, could reflect optimized code rather than brute force creation. Even quantum uncertainty might be a clever shortcut, like a game only calculating precise object positions when players look at them. Bostrom's trilemma presents 3 options. 1. Intelligent species always go extinct before simulating realities. 2. They choose not to run such simulations. Or 3. We're almost certainly living in one. Given humanity's trajectory toward virtual worlds from VR headsets to AI personas, option 2 seems increasingly naive. As for extinction risks, any civilization surviving them would have eons to perfect simulation tech. That leaves option 3 looking uncomfortably plausible. Here's the unsettling kicker. If simulations outnumber base reality, then every layer of existence could be nested. Our simulators might themselves be simulations, like a digital matryoshka doll stretching toward some unknowable original. Occam's razor slices deep. The simplest explanation isn't that we won the cosmic lottery, but that we're living in someone else's math. Time doesn't flow at the same rate everywhere in the universe, and that might be the most telling glitch of all. Einstein revealed that clocks tick slower near massive objects like black holes, a phenomenon called time dilation. But what if this isn't just physics? What if it's the cosmic equivalent of a game struggling to process too many calculations at once, throttling its clock speed to avoid crashing? Picture a high-end video game pushing your PC to its limits. When too many explosions, NPC, and physics objects crowd the screen, the frame rate drops, action slow to a crawl while your inputs lag behind. Now scale that up to a black hole where gravity warps spacetime so severely that time itself grinds to a near halt for an outside observer. From afar, a clock falling toward the event horizon would appear frozen, like a stuck loading icon. But for someone in that gravitational well, time feels normal, just as a player inside a lagging game wouldn't notice their own slowed reality until they compare notes with someone outside. This matches eerily with how simulations optimize resources. Games often reduce update rates for distant or complex objects to preserve performance, a trick called level of detail scaling. Black holes might be the universe's extreme version, regions where the simulation prioritizes stability over real-time accuracy, dialing down local time increments to handle the insane computational load of curving spacetime. Even GPS satellites have to account for tiny time dilation effects just orbiting Earth like a game engine, subtly adjusting tick rates between zones to keep everything synchronized. The real kicker, time dilation isn't symmetrical. Twin astronauts, one on Earth, the other traveling near light speed, will age differently when reunited. In simulation terms, this resembles desynchronization in distributed systems, where nodes process events at varying speeds. The universe might not have a single master clock, but localized servers struggling to stay in sync across vast distances. Black holes could be overloaded nodes. Their extreme time warps a crisis mode to prevent total collapse. So next time you complain about a slow computer, remember, the cosmos might be lagging too. Those cosmic clocks running at different speeds, they're not flaws in reality. They're features of a universe operating at the edge of its processing power. Nature loves efficiency, so much so that it often recycles the same blueprints at wildly different scales. Take a fern leaf, for example. Each frond branches into smaller versions of itself, those branch again, and the pattern repeats down to the tiniest vein. Coastlines do something similar. Zoom in on a satellite image, and the jagged edges of a continent look uncannily like the crags of a single rocky shore. These aren't just pretty coincidences, they're fractal geometry, a mathematical phenomenon where self-similar patterns echo infinitely. But here's the unsettling part: fractals aren't just common in nature. They're downright omnipresent, like a developer reusing the same procedural generation algorithm to save time. Now look up. Galaxy clusters, those massive cosmic webs spanning millions of light years, display the same eerie repetition. Astronomers have found nearly identical arrangements of galaxies separated by vast distances, as if someone copied and pasted sections of the universe's code. The Sloan Digital Sky Survey even identified quasars' extremely bright galactic cores lined up in implausibly precise formations across billions of light years. The odds of this happening naturally, astronomer Lior Shamir calculated them at less than 1 in a million. It's as if the simulation hit Ctrl+C and Ctrl+V while designing deep space. Games use this trick constantly. Open-world titles like No Man's Sky generate planets using fractal math, tweaking a few variables to create the illusion of uniqueness. Minecraft's biomess repeat terrain features algorithmically. Even CGI blockbusters recycle digital assets. The same tree model might appear in 100 scenes, just rotated or resized. If our universe operates similarly, those repeating galaxy clusters could be cosmic stand-ins, placeholders dropped in to fill space without overtaxing the system. Fractals fit too neatly to ignore. Romanesco broccoli, river deltas, lightning bolts, even the branching of your lungs, all follow fractal math with near-perfect precision. In a simulated reality, this makes perfect sense. Why waste processing power inventing new designs when a single equation can spawn infinite complexity? The Mandelbrot set, a fractal generated by a simple formula, reveals endless intricate patterns when zoomed into. It's not a stretch to imagine the universe running on similar code, tweaking parameters to birth galaxies, snowflakes, and neurons from the same underlying logic. So next time you trace the veins of a leaf or gaze at a satellite image of a river basin, ask yourself, are you witnessing the beauty of nature or the telltale efficiency of a universe running on reused assets? The patterns aren't just around us, they might be the very fabric of the simulation, a cosmic Ctrl+C echoing from the quantum scale to the edges of the observable cosmos. Imagine exploring an open-world video game, running toward the horizon, only to watch the landscape suddenly pop into existence just steps ahead. That jarring moment when the game struggles to load terrain is called level streaming. Now consider this: dark matter, the invisible substance making up 85% of the universe's mass, might be the cosmic version of those unrendered zones placeholders, marking where the simulation hasn't fully loaded reality yet. Here's why physicists are stumped. Galaxies rotate so fast that their outer stars should fling into space, yet something unseen grips them with gravitational force. This phantom anchor, dubbed dark matter, doesn't emit or reflect light. We only detect it through its gravitational tug, like finding footprints with no visible creature making them. Current telescopes can't spot it, particle colliders can't create it. The leading theory: exotic particles unlike anything in our standard model. But what if we're overcomplicating it? Video games use proxy geometry, a simplified shape standing in for complex assets until players get close enough for high-detail rendering. Dark matter could serve a similar purpose: temporary scaffolding holding galaxies together in regions where the simulation hasn't fully calculated the intricate dance of stars. Just as a game might use a low-resolution blob to represent a distant mountain, the universe could be using dark matter as a mathematical shortcut to stabilize celestial structures before rendering their finer details. The evidence gets weirder. Dark matter isn't evenly distributed. It clumps in halos around galaxies, leaving vast cosmic voids relatively empty. This matches how games optimize processing power, concentrating detail where players like us are active while leaving barren areas in low-res standby. Even stranger, some galaxies seem to lack dark matter entirely, a baffling discovery unless, like a game forgetting to load certain textures, the simulation simply didn't deploy placeholders in those sectors. Here's the clincher: modified gravity theories like MUND can explain galactic rotations without dark matter by tweaking physics equations. While controversial, they reveal an uncomfortable truth: dark matter might just be a fudge factor, a line of code invented to patch over gaps in our understanding. Games do this constantly. Ever seen an NPC clip through a wall? The engine might teleport them back invisibly to fix the glitch. Dark matter could be the universe's emergency patch, masking the places where reality's physics engine hasn't finished compiling. So next time you hear about dark matter's elusive nature, consider this: we might not be hunting particles at all. We could be reverse engineering the universe's loading screen, waiting for the simulation to draw the rest of the owl. Have you ever walked into a room, met a stranger, or heard a snippet of conversation, and been hit with the overwhelming certainty that you've experienced this exact moment before? That spine-tingling sensation is déjà vu, and while psychologists chalk it up to memory misfires, there's a far more intriguing possibility. What if it's not your brain glitching, but the simulation itself? Think of how video games handle save files. If you reload an older checkpoint, your character retraces steps with eerie familiarity, even though it's technically a new instance. Now imagine the universe doing the same, rewinding slightly to correct an error, then replaying events almost identically. Your consciousness might retain a faint echo of the first pass, creating that unsettling sense of repetition. Game developers call this save scumming, where players reload to undo mistakes. Could déjà vu be the cosmic equivalent, a subtle artifact of the universe rolling back its own clock? Memory glitches add fuel to the fire. The brain doesn't store experiences like a video recording. It reconstructs them on demand, piecing together fragments like a detective solving a case with scattered clues. Sometimes wires cross. A new scene accidentally taps into a similar neural pattern, tricking you into remembering the present. But in a simulation, this fragility makes perfect sense. If reality is rendered dynamically, like a game loading assets as needed, occasional cache mismatches could produce déjà vu. Ever noticed how these moments often involve mundane settings, a hallway, a coffee shop? These high-traffic locations might be prone to reloading, like frequently accessed game levels wearing out their welcome in the system's memory. Even stranger, some déjà vu episodes include precognition. People report predicting the next few seconds, a waiter dropping a tray, a specific phrase in conversation before it happens. Neurologists blame temporal lobe epilepsy or misfiring synapses, but simulations offer a cleaner explanation. If the universe buffers events slightly ahead of conscious perception, like a game pre-loading the next area, brief lags in synchronization could create these prophetic flashes. It's the mental equivalent of seeing a spoiler before the scene finishes rendering. Here's where it gets chilling. In 2006, a team at Leeds University artificially induced déjà vu using hypnosis, proving the brain can fabricate the sensation wholesale. But if a few adjusted neural signals can hijack your sense of reality, how much trust can you place in any of your memories? Perhaps déjà vu isn't a glitch at all, but a scheduled system check, the simulation quietly verifying its own continuity before proceeding. So the next time that uncanny repetition washes over you, ask yourself, are you truly remembering? Or is the universe reloading an earlier save? In 2012, physicists at CERN made history by detecting the Higgs boson, a particle so fundamental they nicknamed it the God particle. Its discovery confirmed why objects have mass at all, filling the last gap in the standard model of physics. But here's the catch: the Higgs field, which permeates the universe and gives particles their heft, feels suspiciously like a clever workaround, a physics patch installed to fix a glitch in the simulation's code. Think of it like this: in early video games, characters would sometimes float unnaturally or clip through walls because programmers forgot to code proper collision mechanics. The solution: invent an invisible force like gravity or hitboxes to anchor everything in place. The Higgs field serves a similar purpose. Without it, particles would zip around at light speed, weightless and untethered. But with this cosmic glue activated, suddenly quarks, electrons, and everything else gain substance, allowing atoms to form. It's as if the simulation's original build had a mass calculation bug, and the Higgs was the hotfix deployed to prevent everything from flying apart. The numbers back up the strangeness. The Higgs boson's measured mass, 125 gigaelectronvolts, is improbably fine-tuned. Increase it slightly, and stars couldn't fuse heavy elements. Decrease it, and atoms would destabilize instantly. This razor-thin margin for error mirrors how game developers tweak variables to balance gameplay. Too much friction and characters move like molasses. Too little and they slide uncontrollably. Even the Higgs' fleeting existence fits. It decays almost immediately after forming. Like a temporary variable the system discards once its job is done. Then there's the hierarchy problem. The Higgs mass should theoretically be 16 orders of magnitude larger due to quantum fluctuations, unless some unseen mechanism cancels it out. Physicists propose elaborate fixes like supersymmetry, but none have been proven. In a simulation, though, this imbalance makes perfect sense. Games often use placeholder values during development, then apply corrections later. The Higgs might be holding the line until the next universe update rebalances the physics engine properly. Here's where it gets wild. Some theories suggest the Higgs field isn't a permanent feature, but a metastable state, like a game running on borrowed time. If its energy level shifts, it could trigger a catastrophic phase transition, rewriting the laws of physics in an instant. Picture a developer pressing reset on a buggy build, spawning a new universe with different rules. The fact that we exist in this precarious balance, neither too stable nor too chaotic, hints at something unsettling. We might be living in a version that hasn't crashed. Yet, so the next time you feel the weight of your body in a chair, remember, that heaviness isn't just physics. It could be the simulation's way of keeping you and everything else from glitching straight through the floor of reality. At the heart of every computer lies a simple, unshakable truth. Information boils down to ones and zeros. Now what if that same binary logic underpins the cosmos itself? Digital physics theorists like Edward Fredkin propose an electrifying idea that the universe isn't just described by math, but built from it, with reality itself processing information like a cosmic supercomputer. And the building blocks might not even be particles or waves, but something far more fundamental: bits. Consider the parallels. Your phone stores photos as binary code patterns of electrical ons and offs. Flip that perspective to quantum mechanics, where particles exist in superpositions of multiple states until measured, collapsing into definite outcomes. Sound familiar? It's the quantum version of a bit flipping from 0 to 1 upon observation. Even qubits, the quantum computing equivalent, mirror this duality, hovering between states until forced to choose. Fredkin took this further, suggesting spacetime itself could be a lattice of discrete cells updating their states based on computational rules, like a cellular automaton game writ large. The evidence hides in plain sight. Ever notice how light comes in indivisible packets called photons, or how electric charge only appears in multiples of an electron's charge? These quantized properties scream digital architecture. In an analog universe, values would slide smoothly, yet nature insists on pixelation, from energy levels in atoms to the Planck-length indivisible space increments. It's as if reality runs on a tick-based engine, updating in discrete steps like a game processing inputs frame by frame. Games expose the logic. In Minecraft, breaking a block doesn't create debris, it vanishes cleanly because the engine only tracks binary states, present or absent. Our universe might operate similarly. Particle collisions don't produce infinite fragments. Outputs follow quantized rules, like a processor adhering to its instruction set. Even causality, the strict law that effect follows cause, could reflect the simulation's sequential processing, with each moment computed before the next renders. Fredkin's most radical insight: the universe might not just compute information, it could be information. Mass, energy, even consciousness might just be particular configurations of data. Think of a DVD's microscopic bits, meaningless alone, but arranged precisely, they encode entire worlds. If reality is a computation, then we're not just players in the simulation, we're the data it's processing. Every thought you have, every star you see, might just be ones and zeros in the cosmic hard drive. Here's the twist: if the universe is digital, it must have a processing limit. Just as your laptop bogs down with too many browser tabs, a finite cosmos would eventually hit computational constraints. Black holes could be nature's garbage collection, collapsing overwhelmed systems into singularity to free up memory. Even the arrow of time might simply be the direction in which the simulation computes its state changes. So next time your computer stutters, take solace: the universe might be buffering too. Neuroscience delivers a gut punch to our cherished belief in free will, and the findings are impossible to ignore. In landmark experiments dating back to the 1980s, researchers like Benjamin Libet wired subjects to EEG machines, asking them to perform simple voluntary acts like pressing a button. The shocking result: brain activity predicting the decision spiked a full 300 milliseconds before subjects reported consciously choosing to act. It's as if our minds announce decisions like a game character's pre-scripted dialogue. We merely hear the lines after they've already been recorded. Modern brain scanners deepen the mystery. Functional MRI studies reveal neural patterns forecasting decisions up to 7 seconds before awareness kicks in. Picture scrolling through a game's dialogue options, pondering whether to help a village or burn it down, except the game already highlighted your choice before the menu appeared. Your illusion of deliberation, just the protagonist's internal monologue catching up to predetermined events. Even spontaneous creativity follows this rule. Jazz improvisers monitored mid-performance show planning activity in prefrontal regions milliseconds before novel melodies emerge like an algorithm generating questlines before the player knows they want them. The implications are staggering. Split-brain patients whose cerebral hemispheres were surgically separated demonstrate even stranger behaviors. When shown different images to each eye, say, a chicken claw to the left eye and a snow scene to the right, one patient's left hand pointed to a shovel for snow while his right hand pointed to a chicken for the claw. Asked why, his language-capable hemisphere fabricated a story about shoveling chicken manure, a post-hoc justification for choices his brain didn't initiate. This isn't just a glitch, it's a feature. Our narrating consciousness works like a game's lore keeper, spinning plausible tales for actions already executed by deeper systems. Games expose the parallels. In Mass Effect or The Witcher, your character has preset dialogue trees. You may choose responses, but the options were coded years earlier. NPC reactions are similarly constrained. Shopkeepers can't suddenly recite Shakespeare because their scripting lacks those lines. Human brains might operate similarly. Genetic wiring and neural pathways form our dialogue options, with consciousness merely selecting from prepackaged choices. Even our sense of deliberation could be the mental equivalent of a loading bar, a progress animation masking fixed computations. Here's where it gets unnerving. Brain stimulation experiments prove external currents can implant voluntary urges. Epilepsy patients with electrodes in their motor cortex reported feeling intentions to move limbs, even when researchers triggered the impulses artificially. If a half-volt zap can manufacture the sensation of free will, how genuine are our everyday decisions? We might be like NPCs convinced we're players, mistaking algorithmic outputs for autonomy. The terrifying beauty, this doesn't make us powerless, just participants in a story whose authorship is more distributed than we dreamed. Ever laugh at a movie you've seen a dozen times or flinch from a jump scare you knew was coming? That stubborn pull of emotion, even when logic says you shouldn't feel it, reveals something unsettling. Your feelings might not be as organic as they seem. Neuroscientists now understand emotions as electrochemical cascades, precise sequences of neurotransmitters firing in response to stimuli, like lines of code executing in a program. Dopamine, that rush of pleasure when you eat chocolate or win a game, operates suspiciously like a built-in reward function, reinforcing behaviors the system wants you to repeat. Video games expose the parallels. NPCs in Red Dead Redemption don't feel anger when you trample their crops. Their scripts simply trigger aggressive animations and dialogue. Yet players attribute emotions to them because the responses feel coherent. Human brains work similarly. When someone insults you, your amygdala doesn't choose to react, it follows preset pathways, flooding your body with cortisol just as a game NPC might switch to combat mode. Even love, that most sacred of emotions, correlates with measurable spikes in oxytocin and serotonin, chemical rewards for social bonding, as if evolution hard-coded them to promote cooperation. The creepiest evidence comes from brain stimulation. In 2015, University of California researchers induced euphoria in depressed patients by zapping specific neural circuits with magnetic pulses. Participants described the artificial joy as indistinguishable from real happiness. If flipping a biochemical switch can manufacture emotions wholesale, how authentic are our everyday feelings? They might be less like soul-deep experiences and more like NPC reactions, prepackaged responses to environmental triggers, playing out on biological hardware. Consider grief. The pain of loss serves an evolutionary purpose, strengthening social ties by punishing abandonment. But in a simulation, grief could simply be a fail-safe to prevent characters from ignoring narrative stakes. Games do this explicitly. If you ignore a quest to save a village, the story penalizes you with guilt-inducing dialogue or tragic cutscenes. our emotions might follow similar narrative logic, coded to keep us engaged in the game of survival. Here's the twist: even empathy, the ability to share others' emotions, shows hallmarks of algorithmic processing. Mirror neurons fire both when you experience pain and when you see someone else hurt, blurring the line between self and other. It's the biological version of an NPC reacting to another character's scripted death with pre-animated sorrow. The terrifying beauty: recognizing emotions as programmed doesn't make them less real, just part of a larger system we're only beginning to debug. So next time rage or joy surges through you, ask, is this you feeling or the simulation running its next subroutine? A patient swallows a sugar pill, convinced it's a powerful painkiller, and their brain responds by actually dulling their discomfort. This is the placebo effect in action, a phenomenon so well documented that it routinely skews clinical trials. But here's where it gets bizarre: your beliefs don't just trick you into thinking you feel better. They physically rewire your biology, releasing real opioids, dopamine, and anti-inflammatory chemicals as if the mind has admin access to the body's source code. Games offer a striking parallel. Ever used cheat codes to tweak a character's health or stamina? Placebo responses work similarly, where sheer expectation flips switches in your neural console. In 2014, Parkinson's patients given fake medication saw their brains produce dopamine levels comparable to real drugs, simply because they believed they'd been treated. It's like entering God mode in a game. The body obeys the command, regardless of whether the input came from a pill or pure psychology. The mechanism is even more precise than we thought. Brain scans reveal that placebo pain relief isn't some vague mental trick. It activates the same opioid pathways as morphine, just without the chemicals. In a simulation, this efficiency makes perfect sense. Why waste resources rendering actual drugs when a simple permissions override, expectation equals analgesia, can achieve identical results? Even the nocebo effect, where negative expectations worsen health, fits the model. Tell someone a harmless electric shock will burn, and their skin inflames as if actually scalded. It's the biological version of a corrupt save file beliefs overwriting default settings. Skeptics argue placebos merely reveal the brain's self-healing potential. But consider this: in 2020, Harvard researchers found placebo knee surgery worked just as well as the real procedure for some patients. Not just pain relief, actual joint function improved despite zero structural repairs. That's not mind over matter, that's mind rewriting matter, like a player using console commands to teleport past a broken bridge instead of fixing it. The simulation doesn't care whether the fix came from physics or faith, it just executes the instruction. Perhaps the most chilling evidence comes from open-label placebos, where patients know they're taking sugar pills and still get better. It suggests the effect isn't about deception, but about tapping into some deeper programming language of the body. Like a game responding to direct input, your cells seem hardwired to accept commands from consciousness itself. So the next time your mood lifts after a friend's pep talk or your headache fades during a convincing TV ad, ask yourself, are you healing, or is someone running a debug script on your biochemistry? You're driving down a rain-slicked highway when suddenly your car skids, time slows as you spin toward an oncoming truck. In that fraction of a second, you brace for impact only to inexplicably regain control unscathed. Most would call this luck, but quantum immortality suggests something far stranger. You didn't survive, you respawned in a parallel simulation where the crash never happened. This mind-bending idea builds on Schrödinger's infamous cat in a box thought experiment. Until observed, the cat exists in a superposition, both alive and dead simultaneously. Only when someone checks does the quantum state collapse into one outcome. Now scale that up to human consciousness. Proponents argue that at every near-death moment, your awareness splits into parallel branches, one where you perish and another where you improbably survive. Since you can't experience being dead, your consciousness seamlessly hops to the timeline where you're still breathing, like a video game reloading your last checkpoint without missing a frame. The logic gets eerier. Quantum suicide experiments imagine a device rigged to kill you based on random quantum events, say, a gun that fires only if a radioactive atom decays. In most timelines, you'd die instantly, but from your perspective, you'd always observe the miraculous survival, no matter how astronomically unlikely. It's like playing Russian roulette with a million chambers and somehow never hitting the bullet because the versions of you that do simply cease to be observed. Here's where simulations amplify the creep factor. If we're already living in a digital construct, these quantum resurrections might not even require parallel universes, just backup saves. Think of open-world games with permadeath modes. If your character dies, the game ends unless the system secretly reverts to an earlier autosave and pretends the death never occurred. Survivor bias would ensure you only remember the timelines where you made it. Real-world cases add chilling weight. Consider those who have walked away from plane crashes with barely a scratch, or patients who flatline momentarily before reviving with inexplicable clarity. Medical studies show some near-death experiencers report heightened senses and lucid memories of events that occurred while their brains showed no activity, as if their consciousness briefly logged into another server before reconnecting. So the next time you narrowly dodge disaster, ask yourself, did fortune smile upon you, or did countless other versions of you perish in unseen simulations, their stories erased while yours continued? The unsettling truth may be that you're not lucky, you're just the only copy left to hit play. Black holes don't just crush matter, they might be the universe's ultimate filing system, cosmic vaults designed to store information at the edge of oblivion. The holographic principle, a radical theory in physics, suggests all the data within a volume of space, every atom, every photon, even your childhood memories, could be encoded on its two-dimensional surface, like a DVD's data etched onto its shiny exterior. And black holes, they're nature's most efficient hard drives, compressing unfathomable amounts of information into vanishingly small singularities, where the laws of physics as we know them cease to exist. Think of how your computer handles storage. When files get too bulky, you zip them into compressed folders, trading space for efficiency. Black holes take this to cosmic extremes. According to physicist Jacob Bekenstein's calculations, the entropy, a measure of information inside a black hole, isn't lost when matter falls in. Instead, it gets imprinted onto the event horizon's surface, pixel by pixel, in patches no larger than the Planck length. It's as if the universe, faced with limited storage, decided to encode three-dimensional reality onto two-dimensional boundaries, like flattening a sculpture into a shadow without losing any detail. Games demonstrate this principle perfectly. Open-world titles like Skyrim can't render every leaf in real time, so they use tricks like low-res textures at a distance, only loading full detail when players get close. Black holes might operate similarly. The holographic principle implies that what we perceive as a three-dimensional universe could be a projection from a two-dimensional surface at its edges, like a cosmic version of a VR headset rendering 3D worlds from flat screens. The event horizon stores all the source code, while the interior is just the rendered output. Here's where it gets stranger. When Stephen Hawking discovered black holes emit radiation, now called Hawking radiation, it sparked a paradox. If black holes evaporate over time, what happens to the information they swallowed? Quantum mechanics insists information can't be destroyed, yet general relativity says it's gone forever. The holographic principle offers a solution. The data isn't lost. It's radiated back out, scrambled but intact, like a corrupted hard drive that still holds its files in unrecognizable fragments. The implications are staggering. If a black hole's entire interior can be described by surface-level bits, then our universe, with all its galaxies and consciousness, might just be a holographic projection from some distant boundary we can't see. It's the ultimate optimization hack, a universe running on the cosmic equivalent of cloud storage, where the physical world is just a rendered illusion. So next time you back up your phone, consider this. The cosmos might have been doing the same thing for billions of years, with black holes as its ultimate USB drives swallowing stars, planets, and maybe even alternate versions of you, all to free up space for the next cosmic update. Those strange lights zigzagging across the night sky, the unidentified aerial phenomena that defy physics as we know them, they might not be visitors from another star system, but beta testers from another server, probing Earth simulation for bugs before full release. Picture this: when game developers roll out a massive open-world title, they don't just hit publish. They invite players into beta environments to stress test mechanics, document glitches, and fine-tune the experience. Now imagine our universe operating the same way, with UFOs as the cosmic equivalent of playtesters' avatars, tweaking parameters in real time. The parallels are uncanny. Military pilots describe tic-tac UFOs executing maneuvers that shatter known aerodynamics: instant acceleration, right angle turns at 6,000 miles per hour, no visible propulsion. These aren't just advanced technologies, they're behaviors that mirror debug commands in a sandbox game, where admins toggle physics constraints to test boundaries. Even the infamous Nimitz encounter fits. When fighter jets attempted to lock onto a UFO, their systems crashed, like a game freezing when players breach developer-only zones. Skeptics call these sensor failures, but what if they're intentional failsafes, preventing unauthorized access to the simulation's backend? Historical accounts add layers to the theory. Ancient texts like the Mahabharata describe Vimanas flying chariots with weapons that blinded entire armies. Medieval paintings depict shield-like objects hovering over villages. Rather than extraterrestrial visitations, these could be artifacts from earlier beta phases, remnants of test runs where developers experimented with different rule sets before settling on our current physics engine. Even modern UFO flaps, waves of sightings clustered in specific eras mirror software update cycles, where new builds deploy patches that sometimes introduce fresh graphical assets or mechanics. Consider how beta testers interact with NPCs in games like Cyberpunk or Assassin's Creed. They might spawn rare items to gauge economy balance or trigger scripted events to measure crowd reactions. UFO encounters often follow similar patterns: cattle mutilations with surgical precision, crop circles encoding complex fractals, even alleged abductions where subjects report medical examinations. These incidents could be stress tests sampling biosphere reactions, probing human neurology under duress, or calibrating pain thresholds in the simulation's NPC population. The most chilling evidence comes from government disclosures. Recent Pentagon reports admit UAPs demonstrate capabilities that defy known aerospace paradigms. If these were merely foreign drones or secret aircraft, why the decades of secrecy? Unless, of course, the truth is exponentially stranger, that those in power suspect but can't prove we're lab rats in someone else's quality assurance trial. When former intelligence official Luis Elizondo hinted that UFOs might be from outer space or potentially another dimension, he could have been describing beta environments separated by version numbers rather than light years. Here's the existential kicker: if Earth is in beta, what's the final product? Are we an early access build destined for major revisions? Or are the glowing orbs and silent triangles we see merely debug tools, cosmic equivalents of wireframe models and hitbox visualizers left visible by accident during routine maintenance? Next time you spot a UFO, ask yourself, are you witnessing an alien or a playtester tweaking the gravity sliders before the universe's official launch? Every night, as you drift into sleep, your brain doesn't just rest, it rebuilds. Dreams, those chaotic narratives that flicker behind closed eyelids, might be more than random neural fireworks. They could be the universe's way of running maintenance, defragmenting your mental hard drive to keep the simulation running smoothly. Think of it like a video game optimizing its save files during loading screens, except instead of textures and quest logs, your mind is sorting memories, pruning useless data, and patching emotional glitches. Sleep studies reveal something startling. During REM cycles, when dreams are most vivid, the brain replays the day's events at high speed, reinforcing important memories while discarding trivial ones. It's not unlike a game caching frequently used assets for faster access while dumping temporary files. Even stranger, the same neural circuits active when you navigate real spaces fired during dreams, as if your mind is stress testing its internal map of reality, ensuring no corrupted waypoints remain. Now consider shared dream archetypes. Falling dreams, teeth crumbling, being chased. These near-universal experiences feel less like personal quirks and more like pre-installed assets in the human experience. Jung called them the collective unconscious, but in a simulation, they'd be system defaults, universal scripts that save processing power by reusing familiar scenarios rather than rendering unique dreams for every user. Ever noticed how dreams often bend physics? Flying, breathing underwater, sudden location shifts. These aren't glitches. They're evidence of the simulation relaxing its rules during downtime, like a game disabling collision checks in a debug mode. The creepiest clue comes from lucid dreaming, where sleepers become aware they're dreaming and seize control. With practice, they can reshape entire dreamscapes, summoning objects, rewriting narratives, even conversing with dream characters who exhibit uncanny intelligence. This mirrors how players use developer consoles to modify game worlds on the fly. If dreams are the simulation's backend, lucid dreamers might have stumbled upon the command line. Then there's the Mandela Effect's eerie cousin, shared dreams. Thousands report identical dream encounters with strangers or locations they've never visited. Some even claim to meet the same dream people, nightly entities with consistent personalities and backstories. In multiplayer games, NPCs reuse dialogue trees to save memory. Could these recurring dream figures be the simulation's NPCs, their limited scripts looping to conserve resources? Here's the twist: sleep deprivation triggers hallucinations, your brain's desperate attempt to keep rendering reality despite missing critical updates. It's the biological equivalent of a game stuttering when overloaded, glitchy polygons flashing where polished graphics should be. Maybe that's why we spend a third of our lives unconscious. Not to rest, but to let the universe recompile. So next time you wake from a bizarre dream, ask yourself, did your mind conjure that, or did you just glimpse the simulation running its nightly system scan? Imagine a universe that's existed for trillions upon trillions of years, a cosmos so ancient that stars have burned out, black holes have evaporated, and space itself has cooled to near absolute zero. In this desolate eternity, something impossible happens. A single conscious mind flickers into existence, fully formed, with memories of a life it never lived. This isn't science fiction, it's the Boltzmann brain paradox, a thought experiment so chilling it suggests reality itself might be a temporary glitch in an endless sea of chaos. And if we're living in a simulation, this phenomenon takes on an even eerier twist. What if consciousness isn't the product of evolution, but a random bug in the system, like corrupted code that accidentally becomes self-aware? The original Boltzmann brain concept comes from thermodynamics. In an infinitely old universe, even the most improbable events like atoms randomly arranging themselves into a functioning brain must eventually occur. Statistically, these disembodied minds should vastly outnumber biologically evolved beings like us. Yet here we are, embedded in a seemingly orderly cosmos. Skeptics argue this proves the idea absurd, but in a simulated reality, the math shifts dramatically. If the universe is code, then consciousness could emerge anywhere the program hiccups, no biology required. Think of it like a video game spawning NPCs with unintended autonomy when a script fails. Ever encountered a glitched enemy in Skyrim that suddenly develops quirky behaviors? Boltzmann brains might be the cosmic equivalent fleeting moments where the simulation's noise accidentally writes a soul. Here's where it gets weirder. Your memories, every birthday, every heartbreak, even the device you're holding now, could be fabricated in an instant by a random fluctuation. You didn't evolve, you just booted up fully formed with a backstory, like a procedurally generated character in No Man's Sky whose entire history is procedurally generated upon first contact. Philosophers call this the problem of empirical adequacy. How do you know your past is real and not just a coherent set of data points rendered the moment you became conscious? In a simulation, the distinction vanishes. Your first memory might have been written 5 minutes ago by a stray bit flip in the cosmic RAM. Video games offer unsettling parallels. Consider the 3 seashells glitch in Grand Theft Auto San Andreas, where an unfinished asset, 3 decorative seashells on a bathroom counter, became infamous when players endowed them with mythical significance. The shells were never meant to be interactive, yet the community treated them as sacred objects. Now imagine a simulation where random noise generates not just artifacts but thinking entities. A Boltzmann brain wouldn't need neurons, just the right arrangement of quantum fluctuations or corrupted data packets to spark awareness. The nightmarish twist. Boltzmann brains should experience mostly madness. A brain spawned from chaos would likely remember impossible events or perceive a nonsensical reality. But here's the catch. A coherent, stable consciousness like yours couldn't distinguish whether it evolved normally or emerged randomly with perfectly fabricated memories. Like an NPC in a game suddenly gaining sentience, you'd have no way to verify if your world was designed or accidental. The simulation could have started 5 seconds ago, preloaded with your past, and you'd never know. This isn't just philosophy. Quantum physics allows for virtual particles to pop into existence from nothingness, a phenomenon observed in labs. If empty space can briefly conjure particles, why not a fleeting mind? Some interpretations of quantum mechanics even suggest consciousness plays a role in collapsing probability waves into reality. In that case, a Boltzmann brain wouldn't just observe the universe, it might briefly become the universe, a ghost in the machine witnessing itself before dissolving back into noise. So the next time you feel a sense of déjà vu or stumble upon an inexplicable coincidence, consider this. You might not be the protagonist of reality's story. You could be a cosmic typo, a self-aware smudge on the universe's ledger here just long enough to wonder before the simulation hits Control plus Alt plus Del. From ancient cave paintings to blockbuster films, the idea that reality might be an illusion has captivated humanity for millennia. But why does this notion, once the domain of fringe philosophers, now dominate mainstream conversations? The simulation hypothesis didn't just go viral, it tapped into something deeper, a collective intuition that transcends cultures and eras. Look at Plato's allegory of the cave, written 2,400 years ago, describing prisoners mistaking shadows for reality. Fast forward to Buddhism's concept of Maya, the veil of illusion obscuring true existence. Even Descartes pondered an evil demon deceiving his senses. This isn't coincidence, it's pattern recognition on a species-wide scale. Modern media amplifies the signal. The Matrix didn't just entertain, it crystallized suspicions simmering in the public subconscious. Its red pill metaphor became shorthand for questioning reality itself, spawning memes, political slogans, and even Silicon Valley buzzwords. Tech billionaires pour millions into simulation research, while physicists like Neil deGrasse Tyson openly debate the odds we're living in code. This isn't niche speculation anymore, it's water cooler talk. The theory's surge mirrors how urban legends spread, but with one key difference. Instead of vanishing under scrutiny, it gains credibility with every quantum physics breakthrough and AI advancement. Here's the unsettling angle. What if this resonance isn't accidental? In psychology, the mere exposure effect shows we favor ideas we've encountered before, even subconsciously. Could the simulation hypothesis feel familiar because on some level we recognize it? Ancient astronaut theorists suggest myths of gods creating worlds might be distorted memories of ancestral simulators. But there's a darker twist. What if the concept propagates because the simulation itself allows it? Imagine a game where NPCs start suspecting they're in a game. A robust system wouldn't erase those thoughts. It might steer them into predictable tracks, turning revelation into just another scripted narrative beat. The numbers don't lie. Google searches for simulation theory spiked 1,200% after Elon Musk's infamous 1 in billions comment. Universities now offer courses on digital physics. Reddit forums dissect glitches like Mandela effects with forensic zeal. This isn't just curiosity, it's mass cognitive dissonance, the collective mind straining against its perceived limits. Perhaps that's the most telling evidence of all. When an idea persists this stubbornly across centuries, maybe we're not just exploring a theory, maybe the theory is exploring us. Empty space isn't actually empty. If you could zoom in past atoms, past quarks, down to the Planck scale, you'd find a seething froth of virtual particles popping in and out of existence like static on an old TV screen. Physicists call this quantum foam, and its chaotic dance might be the universe's way of masking background processes, the humming, glitching machinery of the simulation itself struggling to keep reality rendered smoothly. Picture your computer's task manager. Even at idle, dozens of background processes run unseen, from system updates to antivirus scans. Now imagine the cosmos operating similarly. Quantum foam, those fleeting particle-antiparticle pairs, could be the simulation's way of handling housekeeping tasks. When particles briefly form from nothingness before annihilating, they're not just quirky physics. They might be the cosmic equivalent of memory leaks or cache refreshes, tiny sacrifices of processing power to maintain stability. This would explain Heisenberg's uncertainty principle, which states you can never perfectly measure both a particle's position and momentum. In a simulation, that's not a law, it's a limitation. Just as your laptop throttles performance when overheating, the universe introduces quantum noise to prevent perfect calculations that could crash the system. Games demonstrate this same tension between detail and performance. In open-world titles, distant terrain often shimmers with graphical artifacts, not because the designers wanted it, but because the engine cuts corners to preserve frame rates. Quantum foam could be our universe's version of those artifacts, visual proof that the simulation prioritizes smooth operation over pixel-perfect precision. Even the Casimir effect, where two metal plates in a vacuum inexplicably attract each other, fits the model. The plates squeeze out virtual particles from the space between them, creating a pressure imbalance. It's as if the simulation, forced to reduce calculations in that narrow gap, opts for a quick fix, pulling the plates together to simplify the math. Here's where it gets eerie. Virtual particles aren't just mathematical tricks, they have measurable effects. Hawking radiation, the glow that makes black holes evaporate, relies on these ghostly particles splitting at event horizons, with one falling in and the other escaping as real energy. In a simulation, this looks less like physics and more like resource management, the system culling excess data to free up memory. Even the zero-point energy of space, that infinite sea of potential lurking beneath reality, could be the simulation's idle state, the hum of an engine waiting for the next command. The unsettling implication, what we call reality, might just be the clean, user-friendly interface masking a far messier backend. Quantum foam, with its endless particle flux, could be the static bleeding through from the universe's source code, a reminder that behind every galaxy, every thought, every law of physics, there's an engine churning in the dark, barely holding it all together. So next time you stare into the night sky, remember, the silence of space isn't silent at all. It's a cacophony of ones and zeros whispering in the void. Why does the universe seem custom-built for life? The fundamental constants of physics, gravity's strength, the electromagnetic force, even the precise mass of electrons, are balanced on a knife's edge. Tweak anyone by a fraction and stars wouldn't ignite, atoms would fly apart, and life as we know it couldn't exist. This eerie perfection is called the anthropic principle. The universe appears fine-tuned because, well, we're here to observe it. But that explanation feels suspiciously circular, like congratulating yourself for winning a rigged game you didn't know you were playing. Could there be a deeper reason these dials are set so precisely? Take gravity, for instance. If it were just slightly stronger, stars would burn out in mere millions of years, too quickly for planets to form or life to evolve. If weaker, matter would never clump into galaxies at all. The cosmological constant, which dictates how fast space expands, is even more baffling. Calculations suggest its natural value should be 120 orders of magnitude larger than observed. If it were, the universe would have torn itself apart instantly after the Big Bang. Yet here we are, in a cosmos where this number is dialed down to an unimaginably precise sliver of possibility. The odds, like rolling a dice and getting the same number a trillion times in a row. This isn't just cosmic luck. Mathematician Roger Penrose calculated the probability of all necessary constants aligning by chance at 1 in 10 to the power of 10 to the power of 123, a number so large it defies analogy. Even the most hardcore skeptics admit something's up. Enter the simulation hypothesis. If our universe is designed, whether by aliens, future humans, or some higher dimensional architect, fine-tuning becomes trivial. Just as a game developer tweaks a virtual world's parameters to make gameplay possible, a simulator could have adjusted physics to allow conscious observers. Earth isn't a fluke. It's a deliberately crafted stage, a Goldilocks zone where the code permits players to spawn. Games illustrate this perfectly. In No Man's Sky, planets with breathable atmospheres and liquid water are rare by design, funneling players toward hospitable zones without explicitly signposting them. Minecraft's world generation ensures trees spawn near dirt, and pigs drop pork chops, rules that don't exist in nature but make the experience functional. Our universe might operate on similar hidden logic. The weak nuclear force's precise strength allows carbon, the backbone of life, to form in stars. The strong force's exact ratio binds atomic nuclei without making them inert. These aren't accidents, they're features, carefully coded constraints that let the simulation's NPCs, that's us, run without crashing. The creepy twist. The anthropic principle might not just explain why constants are life-friendly, it could hint at something darker. If countless simulations exist, most would terminate quickly due to bad parameters. Only the rare versions where everything aligns perfectly would persist long enough for observers to arise. In other words, we might not be in a finely tuned universe. We might be in the only one that didn't glitch out immediately, a cosmic error screen that, by sheer luck, became self-aware. So when you marvel at a sunset's beauty or the miracle of DNA, remember, you're not just witnessing nature's perfection. You're browsing the README file of a universe that, against all odds, booted up correctly. Darwin's theory of evolution paints a breathtaking picture: random mutations filtered by natural selection, sculpting life's riotous diversity over billions of years. But what if this elegant process isn't nature's masterpiece, but a procedural generation algorithm coded into the simulation? Think about how video games create infinite worlds without handcrafting every detail. No Man's Sky uses mathematical formulas to spawn unique planets, each with its own flora, fauna, and ecosystems. The simulation might be doing the same thing, deploying Darwinism as its go-to algorithm for procedural biodiversity, a cosmic version of pressing generate and watching life autofill. Consider the uncanny efficiency of evolution. From the genetic code shared by all earthly life to the way convergent evolution molds similar solutions in unrelated species, like wings evolving independently in bats, birds, and insects, it all feels suspiciously optimized. In a simulation, reusing code is standard practice. Why reinvent the wheel for every species when a few elegant rules can produce endless variations? Even the apparent waste of extinction events fits. Game developers routinely cull underperforming assets to free up memory. The dinosaurs' demise 65 million years ago might have been less a catastrophe and more a system purge, clearing RAM for the mammalian update. Look at DNA itself, a 4-letter chemical alphabet scripting everything from oak trees to octopuses. Digital systems thrive on binary simplicity. DNA's ATC pairs mirror this efficiency like a biological zip file compressing unfathomable complexity into tidy base pairs. Mutations, once seen as random errors, could instead be deliberate noise injected into the algorithm evolution's way of stress testing new traits before deploying them. CRISPR gene editing technology reveals how easily life's code can be hacked, as if we're reverse engineering the simulation's developer tools. The fossil record adds another layer. Life explodes in complexity during events like the Cambrian explosion, as if the simulation patched in a major content update. Stasis periods, where species remain unchanged for eons, resemble buffering holding patterns while the system prepares the next adaptive leap. Even sexual selection, with its extravagant peacock tails and elk antlers, mirrors aesthetic choices in procedural generation, where algorithms prioritize visually striking variations to enhance immersion. Here's the twist: evolution's greatest trick might be convincing us it's unguided. In a simulation, apparent randomness often masks underlying rules. The random shuffle of a music app follows precise algorithms. Evolution's chaos could similarly cloak a deterministic process. When we simulate artificial life in labs, simple rules yield astonishing complexity, just like Conway's Game of Life, where basic cellular automata birth intricate patterns. Our universe's biodiversity might be no different, its code elegant enough to mimic serendipity while running on rails. So next time you marvel at a hummingbird's hover or a fern's fractal spirals, ask yourself, are you witnessing nature's improvisation or the output of a procedural generation script humming along in the background since the first amino acids booted up? Here's the most unsettling possibility of all. What if you're the only real thing in this entire universe and everything else, from distant galaxies to your closest loved ones, are just elaborate background characters in a cosmic game designed solely for your consciousness? This isn't just philosophical navel-gazing. It's solipsism taken to its extreme, a theory that suggests your mind is the only certainty and the entire external world might be an illusion. Think of it like playing a single-player RPG where every other character is scripted, their emotions pre-programmed, their reactions pixel-deep. The twist: you're not just the protagonist, you're the only player. Lucid dreaming offers a chilling parallel. In these hyper-vivid states, dreamers become aware they're asleep and seize control, bending the dream's rules like a hacker accessing developer mode. They fly, summon objects, even rewrite the narrative, all while the dream's NPCs, your sleeping brain's version of non-player characters, react with unsettling coherence, as if programmed to maintain the illusion. A dream person might argue passionately with you or weep real tears when told they don't exist, their emotional depth indistinguishable from real people. Now scale that up to waking life. If your brain can generate convincing standalone consciousnesses offline, why assume the waking world's inhabitants are any more autonomous? Science blurs the lines further. Princeton's Global Consciousness Project found random number generators spiking in coherence during global events like 9/11, as if collective attention briefly synchronized the simulation's background noise. Quantum mechanics adds fuel. Particles behave differently when observed, almost as if the universe conserves processing power by only rendering what's being watched. Even your senses are unreliable. The brain constructs reality from fragmented inputs, editing out blind spots, smoothing motion blur, even fabricating entire scenes during saccades, those tiny-eyed jumps you don't notice. It's not a stretch to wonder, if perception is this malleable, how much of shared reality is just your personal render? Games like the Stanley Parable or BioShock toy with this horror. NPCs break the fourth wall, addressing you, the player, not your avatar. In Westworld, hosts repeat scripted loops until guests, the true players, interact, sparking tailored narratives. Our universe might operate similarly. Ever met someone who felt off, reciting canned small talk like a dialogue tree exhausted its options? Or witnessed crowds move in eerie sync at airports or stadiums, their paths too perfectly optimized? These could be nothing, or they could be moments when the simulation's NPC routines glitch into visibility. The darkest implication if you're the player who's the game for. Ancient mystics spoke of the veil of Maya, the illusion separating souls from ultimate reality. Modern transhumanists hypothesize we're simulations run by post-human civilizations. But the solipsistic version is lonelier. There is no deeper layer. You're not a character in someone else's game. You're the entire audience, the only consciousness that ever existed, trapped in a self-generated holodeck where every smile, every sunset, every whispered "I love you" exists solely to keep you engaged. Yet here's the paradox that keeps philosophers up at night. Even if this were true, you could never prove it. The moment you interrogate an NPC, "Are you real?" The simulation would generate a plausible denial, just as dream characters do. The only escape is to play along, to accept that whether this is base reality or a solo campaign, the stakes feel real enough to matter. So the next time you lock eyes with a stranger or feel rain on your skin, ask yourself, are you sharing a moment, or is the universe rendering yet another breathtaking cutscene just for you? We've wandered through 30 layers of cosmic strangeness, quantum pixels flickering in and out of existence, math that feels too perfect to be accidental, even the unsettling possibility that everyone around you might just be background characters in a universe-sized RPG. But if there's one thing that ties all these threads together, it's the cracks, those fleeting moments when reality stutters, revealing the scaffolding beneath. The Mandela Effect, where thousands misremember the same details, black holes behaving like corrupted save files, swallowing information whole, dreams that feel less like random neural static and more like debug mode for the simulation. Even the way particles cheat, communicating faster than light should allow, as if the universe's physics engine is cutting corners to save processing power. Then there's the math, not just the Fibonacci sequences hidden in galaxies and seashells, but the fact that math exists at all, an invisible language the cosmos seems to obey with robotic precision. Why do abstract equations scribbled on a chalkboard predict the spin of electrons or the orbits of planets unless they're glimpsing the source code itself? And let's not forget the NPC dilemma, the way human behavior often follows eerily predictable scripts, like non-player characters stuck in dialogue loops until a real player walks by. So here's the real question. If this is all a simulation, what's your role in it? Are you the player, the glitch, or just another line of code following its programmed path? Until we know for sure, keep your eyes open. That déjà vu moment, the odd coincidence that feels staged, the dream that lingers a little too vividly, they might not be random. They could be clues, so stay curious. What bugs have you spotted in reality lately? Drop them in the comments. We're all detectives in this cosmic mystery together. And if you're hungry for more mind-bending deep dives, hit subscribe. The universe is stranger than we think, and we're just getting